In this video, I would like to look at the example where I'm going to use the definition of the definite integral in terms of signed area to compute the integral from 7 to 0 of 2x minus 4 with respect to x. Now, to get started, the very first thing that we want to do is we want to draw a picture of the situation. So let's get started with drawing an xy coordinate plane, and I know that y is equal to 2x minus 4 is a straight line, and it happens to have slope equal to 2. So let's draw a line that is fairly steep, like so. And what I'm going to do is I'm going to label some points on this particular line. This point here is going to be the point 0 minus 4. That's on my line. We're going to use this as the upper endpoint. So this is going to be 7, let's see, I guess that would be 14 minus 4. So that's going to be the point 7, 10. And I'm going to drop something down there. So this is x is equal to 7. And this point here, where the line crosses the x-axis, that point is going to be the point 2, 0. Because if you put 2 into the formula, y is equal to 2x minus 4. When x is equal to 2, we would get 4 minus 4, which of course is 0. Now, there are two chunks of area that we can easily see. I'm going to call this triangle A1 and this triangle A2. Now, what I want to notice is that in the integral that we're trying to compute, we are integrating in the wrong fashion. We are going from this point here back towards x is equal to 0. And so this is going to tell me that this particular integral is going to be minus the area above the x-axis and add back the area below the x-axis. So in other words, from this picture, I can see that the integral going from 7 to 0 of 2x minus 4 dx is going to be minus a2 plus a1, where I'm looking at a1 and a2 as just the areas of triangles. So now I want to think in terms of what is a1, what is a2. Well, let's see. This distance here is 4, and this distance is 2. So a1 as just a triangle is going to be 1/2 times 2 times 4. So A1 as just a triangle has area equal to 4. And at A2, when I look at it, this distance down here is 5, and this distance here is 10. And so A2 is going to have area 1/2 5 times 10. Area 2 is going to be 25 square units of area, because that 1/2 is going to divide into that 10 and give me 25 times 25. Now, in terms of signed area, the integral that we're trying to compute here, that goes from 7 to 0 of 2x minus 4 dx, well, let's see, a2 is above the x-axis and we're going in the wrong direction, so I want minus 25, and then I want to add back area a1, and a1 is 4, so I would get an answer of minus 21. And that would be what this particular integral would actually be equal to. Now, I want to make one observation. If I look at the integral going in the right direction, I go from 0 to 7 of this same function. That would be the area above the x-axis minus the area below the x-axis, And so this would be, let's see, it would be a2 minus a1, and that would be 25 minus 4, which would be 21. So it turns out that the two integrals, this integral here and this integral here, are additive inverses of each other. And that's true in general. And so I want to kind of make that observation as its own particular fact. So, a basic fact. If I integrate between a and b of f of x dx, and here we're going to let a be less than b, then this is going to be the area above the x-axis. Subtract off the area below the x-axis. But if I integrate in the wrong direction, then I'm going to get minus the area above the x-axis, add back the area below the x-axis. And what I can do is I can factor out a -1 here. So I can say that this is minus the area above the x-axis, subtract off the area below the x-axis. Because this minus sign is going to multiply both of these two terms. And now what I'm looking at is I'm looking at minus the integral of from a to b of f of x dx. And so we have a very basic important fact about all definite integrals. And the fact is that if I look at the integral between a and b of f of x dx, and I look at the integral between b and a of f of x dx, these two things are additive inverses of each other. And so I can put a minus sign here and an equal sign there.